If it's C-centered, then this is a unit cell, smaller. So the conventional had chosen monoclinic C as the conventional one. So conventional means that, okay, we found that monoclinic I equal to monoclinic C. So all the crystallographer, they sit down and then they decide that they want to pick this one, the smaller one, monoclinic C. So they neglect the monoclinic I. Same thing apply to here. They choose the smaller one, monoclinic C, and they neglect the monoclinic F, the face center. Okay. So basically, it just show that B equal to P, and then C is not equal to P. Therefore, we have two types. We have C, and we have also P, because C cannot equivalent to P. The C base cannot equivalent to primitive. So out of 7 crystal system, we will only emphasize on the cubic. Okay, 7 crystal system, we have triclinic, monoclinic, orthorhombic, tetragonal, cubic, trigonal, and hexagonal. But in this solid state physics course, we will only emphasize on cubic. Why cubic? Because cubic have the simplest parameter, all 90 degree, then all have the same length. Okay, so we just want to make everything easier so that you can understand more. So we want to give you the simplest case, which is the cubic. So for cubic, we have 3 types: primitive, I, and F. For primitive, we normally call it as simple cubic, okay, SC. I, we normally call it as body-centered cubic, and F, we call it as face-centered cubic, FCC, BCC, and SC. So now we only emphasize on cubic lattices. 3 types: simple cubic, we call it SC. Body-centered cubic, we call it BCC. Symbol is I. Simple cubic, the symbol is P. Face-centered, F, and then we call it FCC. Okay. Along Y direction and along Z direction. Okay, and then all the angle are 90 degrees Celsius. So the conventional cubic shell of simple cubic, body-centered cubic, and face-centered cubic have 1, 2, and 4 lattice pointers respectively. For simple cubic, I think there should be no problem. This simple cubic only has 1 lattice point or 1 atom per unit cell. Why? Because, okay, this is 3D. If I draw in 2D, so I draw in 2D. So this atom. So this is cubic, right? This is cubic. Although it doesn't look like cubic, but you just assume that this is cubic. So, okay, I want to change the color. This atom is actually shared by 4 unit cells, right? So this atom contribute 1/4 to this unit cell, 1/4 to this unit cell, 1/4 to this unit cell, 1/4 to this unit cell. Get it? So for 1 unit cell, we have 1/4 plus 1/4 plus 1/4 plus 1/4. So 4 times 1/4 equal to 1 lattice point for 2D. Okay, so now we proceed to 3D. For 3D, each atom is shared by the other 8. So 8 times 1/8. Okay, that means that this atom is shared by the other 8 unit cells. You can imagine 1, 2, 3, 4, and then the top one another 4, so 8. You just imagine that. Can you imagine the cubic For the cubic, each atom is shared by another 8 unit cell. But for 2D, each atom is shared by another 4 unit cell. But 3D, there are, I think it's really very difficult for me to explain. But just imagine okay, just imagine that in 3D cube, like you stack the cube, then the center, the corner atom, always shared by the other 8 unit cell, right? So the portion contribute to 1 unit cell is only 1/8. 1/8. So 1/8. Then this is 1/8, 1/8, 1/8, 1/8, 4, 5, 6, 7, 8. 8 times 1/8. So you will get 1 lattice point. So for simple cubic, there's only 1 lattice point. Okay. How about body center cubic? So this is a structure for body center cubic. We know that all the corner atom or all the corner lattice point will only contribute 1/8, and there are 8 corner lattice point. So 8 times 1/8 equal to 1. So the corner one, the contribution contribute to 1. How about the center one? The center one 100% belong to this unit cell. Okay, so the contribution is 1. So 1 plus 1 equal to 2. Therefore, the conventional cubic cell of body center cubic have 2 lattice point. Okay, this is how the 2 lattice point come from. Next, how about face center cubic? Face center cubic look like this. So we have atom at the corner in 2D, let's say. And then face center cubic, the atom is located here. Okay, so this atom basically, or this atom or lattice point basically is shared by 2 unit cell. 1 unit cell, 2 unit cell. Right. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1/8. These are the corner one. Corner contribute 1/8 only. And then the face center, this is the face center one. So this only shared by 2 unit cell only. 1, 2, 3, 4, 5, 6, 7. And then where's the last? No, this is not. Okay, so there's only 6. 1, 2. Okay, I redraw again. 1, 2, 3, 4, 5, and then the red one, 6. So 6 times half equal to 3. Then plus 1/8 times 8 equal to 4, right? This come from the contribution of the face-centered atom or lattice point, and then this come from the black one, the corner one. So the total lattice point for face-centered cubic is 4. So however, the primitive cell have 1 lattice point. Primitive cell means simple cubic lah. Okay. The characteristic of simple cubic, body centered cubic, and face centered cubic are summarized in next table. Okay, this table. I will go through one.